Hi everyone, it's Mrs Jennison here. I'm an Associate Director for Outward Grange Academy's Trust and welcome to our next video. This lesson is on glass, composites and ceramics and is aimed at our triple science students. Our challenge today is to be able to describe how glass, ceramics and composites are made. Our aspire is to be able to explain how the properties of these materials can link to their uses. Now the first material we are going to look at is glass. Most of the glass that we use is something called soda lime glass. This is made by heating a mixture of sand, sodium carbonate and limestone. Now I'm going to play you a video on this. It shows you this process really well. If you wish to watch the original video for the full duration, the link is on the screen.
You know, it's such a simple, routine act of everyday life, opening and closing a window.
Yet I'm not really sure how or why this window glass started out as a heap of sand. So how do you go from sand to a perfectly clear window?
Are you still here? The story of windows starts here, way up here, 60 feet off the ground in Carlisle, Pennsylvania at PPG. These are giant, massive silos that hold the key ingredients to glass.
The main one, sand. Every day, 800 tons of it are fed into the building here and then mixed with two elements critical to the manufacture of window glass: soda ash and lime, or sodium carbonate and calcium carbonate. They lower the melting point of silica sand and alter its basic molecular structure.
These chemicals soften the glass. They make it easier to melt, they terminate the silicon-oxygen chains, and make a more manageable glass to work with. And that soda lime silica glass lies at the heart of every window.
Now, all of our raw materials have been mixed together and dumped into tanks like these, where it's a cool, 3,000 degrees. It's actually hotter than molten lava. And it will take 3 days for a single molecule of sand to get from this point all the way to the other end of the factory, where it actually starts to resemble a sheet of glass. All right, so we're wearing this protective garment for a reason, right?
Right. We're wearing Kevlar gloves, fire retardant.
We're dressed like big oven mitts.
Right.
Yeah, it's pretty hot where we are, but it's going to get a lot hotter in a second, right?
Yep.
So let's rake.
Steve Anderson and I have to rake this batch quickly. The goal? Well, don't let the rake melt first and spread out the mix to reduce air pockets that might form.
Yeah. We're pulling that whole raft over to the wall.
Yeah, it's like tapping.
Yeah, just like that.
It doesn't take long for the batch to start looking less like sand and more like an overflowing volcano. The only way to see this river of glass is through these polarized metal masks. Without them, your vision will be, well, gone. There, inside that shiny surface on the bottom, that is liquid glass. For 10 hours, the molten mix is superheated behind thick walls to allow gas to bubble up and out.
Soda lime glass has a really low melting point, so it's frequently not very useful when you are heating something to a high temperature. So if you are doing that, you use a different type of glass. This is called borosilicate glass. It's made in the same method but with different reactants. So this type of glass has a much higher melting point and it's made from sand and boron trioxide. Objects made from clay ceramics are made by shaping wet clay and then heating this in a furnace. Most composites are made of two materials, a matrix or a binder, surrounding and binding together fibres or fragments of another material. That is referred to as the reinforcement. Examples include fiberglass and carbon fibre. And I'm going to insert a video here that shows this process and gives you a few more examples. If you wish to watch the original video, the link is on the screen.
Composites are made up of at least two distinct intended materials which together improve product performance and/or lower manufacturing costs. Many materials routinely designated by other terms are also considered composites, including plated, clad, or coated metals. The term composite, however, has come to mean a material consisting of a matrix or base material and a reinforcement material. The matrix functions as a binder for the reinforcement and controls the physical shape and dimensions of the part. The primary purpose of the matrix is to transfer the load or stress applied to the composite to the reinforcement. The matrix also protects the reinforcement from adverse environmental effects. The reinforcement's function is to improve the mechanical properties of the composite and is typically the main load-bearing element. Reinforcement is usually in the form of fibers or particles.
Now that we've gone through those, what I'd like you to do is I'd like you to tell me what the raw materials are for each of those materials. So soda lime glass, borosilicate glass, clay ceramics and composites. So for soda lime glass, we use sand, sodium carbonate and limestone. To make borosilicate glass, we use sand and boron trioxide. Clay ceramics is clay heated with a furnace. And composites have two materials, a matrix or bonder with the reinforcement material added into it. Now, why is this important? We currently live in a world where we must reduce our use of plastics. It has become unsustainable for us to continue with our use in the way that we have been doing. This means that we may be using more of these materials in future, so we may have to use more glass where we would have usually used plastic or ceramics, etc. As with any material, we must look at the properties and the advantages and disadvantages before we decide which is the most suitable for a given use. So that's the next part of our lesson, and we're going to start to look at some specific properties of each of these materials. So what I'm going to do is I'm going to give you a little bit of time, and what I'd like you to think of is I'd like you to write a little list of the properties of composites, and then use that list to give some advantages and disadvantages of that as a material. Okay, so some common properties of composites. It's quite difficult for this one because there's so many different types of composites. But the general list is that they are strong, and that's due to those fibres. They are opaque, they are typically water resistant, they're easy to mould into shape, they have a wide range of properties dependent on that composite in question. So for example, composite wood such as chipboard is significantly cheaper than wood like pine because it's made out of fragments. However, composite doors are more expensive than wood doors, so cost doesn't always work the way in one way with composites. They typically also have quite a low density. Now, advantages and disadvantages, again, this is dependent on the material. However, they can be cheaper, especially when you're talking about wood. There is many variations available as they are specifically designed for certain uses. They have a low density, which is good in terms of transport, and they are waterproof. The disadvantages, they can break and then they need repairing, and that can't just be a patch up, it has to be done with the exact same material. They can sometimes be expensive and the manufacture is quite slow. So now let's have a think about glass. This should be a material that we're a little bit more common with. I'd like you to list the properties of glass and then give me some advantages and disadvantages of glass. Okay, so some properties of glass. Again, it's waterproof, it can be recycled, which is really useful. It keeps its shape, although it is brittle, and glass when it breaks is quite dangerous. It has got a high density if you compare it to plastic. It has a low melting point unless you use borosilicate glass, and it's translucent, so if you're using it as a container, you'll be able to see the contents, which is definitely an advantage for glass. So if we start to look at some advantages and disadvantages, as there's translucent there on the bottom, it's pretty cheap, but the disadvantage is you are using finite materials. Now, sand is a finite material, we just have a very plentiful supply. So if you're comparing this to crude oil, which is the raw material for plastic, they're both finite materials, but we've got a bigger supply of sand. Glass is waterproof and it can be recycled and reused. It's easily cleaned. Disadvantages, it's brittle, so if it breaks, it can actually hurt people. And because of that higher density, it's also going to have quite high transport costs. Because remember, your load has a weight and a size limit. So if you've got a higher density, you wouldn't be able to transport as many bottles of glass as you would plastic. So now let's have a think about ceramics. Again, I'd just like you to list properties of ceramics. I've put some images of different examples of ceramics on the screen, because obviously there's lots of different examples, but typically pottery, but also technically bricks are classed as a ceramic, so that might help you with some of the advantages and disadvantages. So some properties of ceramics: they are strong, they are opaque, water resistant, easy to mould into shapes, they have quite a very high density, this is even higher than glass, and they are flame resistant. They are also brittle, but not as brittle as glass. Some advantages and disadvantages: they're quite cheap, there's many different variations available, they're waterproof and they can be reused. However, they can't be recycled, which is a disadvantage. They're made out of finite materials again, but it's a finite material that we do have a large supply of. They are brittle, but not as brittle as glass. And again, if it breaks, it can hurt people. And again, we've got a much higher transport cost. Now, so this is a typical exam question on this topic, and there hasn't been many so far. What they're typically asking at the moment is for you to compare one of these materials to an existing material. So in this case, we're going to compare it to plastic, but you could even compare these materials between each other. The main reason for that is because they expect you to know information on these materials. So that's where you can bring in those linking statements. So we're going to read through this one together, and then I'm going to give you some time to answer it. If you need a little bit more time, pause the video, finish your answer, and then we'll go through the mark scheme afterwards. So, plastic and glass can be used to make milk bottles. The table below gives information about milk bottles. We are going to be asked to evaluate these milk bottles, which means we're going to have to give the pros and cons of each and use that to form a justified conclusion. So let's have a look at what information we've got. We've got the raw materials, so these are either going to be renewable or finite, and which material is being used to actually make the bottle. Then we've got initial stages in production and the maximum temperature during that production process. Now, if that's high, that's going to have higher energy implications. We've got the number of times the bottle can be used for the milk and the sizes that are available. And you've also been given the percentage of recycled material that's being used in new bottles. So once you've gone through all that information, they want you to evaluate the production and the use of bottles made from soda lime glass and those made from HD polyethylene. They want you to use the information given and your own knowledge and understanding to justify your choice of material for those milk bottles. Okay, so as always with these 6-mark evaluations, we are aiming for that level 3 answer, which means we need a detailed and coherent argument which considers a range of the issues and comes to a conclusion. So, some indicative content you could have included in your answer. The glass has got 2 stages in production, and the second stage is the heating of the reactants, whereas the HDPE has 3 stages in its production. Now, typically more stages equals more cost. It also makes it slower, so glass production could be quicker. A higher temperature is used in glass manufacture, so there's a higher energy requirement, but the glass bottle can be reused significantly more times. There must be cleaning and collection costs involved in that though. Other glass products could be made from recycled glass. Plastic has a higher range of sizes. Both are being produced from limited raw materials, however there is more sand available than crude oil. There's a higher percentage recycled materials in the glass, which will conserve some raw materials. So if you've got a balance between commenting about glass and the plastic, and you've got comparative points between the two, and you've summarised with which you think is best, then you would get full marks for that answer. So that's everything for this video, and I will see you soon. Take care.